Hello, and welcome to AWS Academy Cloud Operations. In this segment, you will learn about the scope and duration of the course. We also discuss where to find documentation for Amazon Web Services. This course has several prerequisites. First, you should have general knowledge about information technology, such as file management and how to navigate the internet. Second, you should have general knowledge about how businesses use information technology. Ideally, you will also have some knowledge of distributed systems and be aware of general networking concepts and multi-tier systems architecture. We recommend taking the AWS Academy Cloud Foundations course if you have no prior AWS cloud experience. At the end of this course, you will be able to describe infrastructure as it relates to system operations, including the global infrastructure, core services, and account security. You will also be able to use the AWS command line interface and software development kits to interact with the services. You'll also be able to manage, secure, and scale compute instances on AWS, including container services, AWS services that are available for serverless computing. Manage, secure, and scale databases on AWS, build virtual private networks with Amazon Virtual Private Cloud, configure and manage storage options using the storage services offered by AWS, monitor the health of your infrastructure with services such as Amazon CloudWatch, AWS CloudTrail, and AWS Config. Manage resources in your AWS account by using tags, Amazon CloudWatch, and AWS Trusted Advisor. Create and configure automated and repeatable deployment with tools such as Amazon Machine Images and AWS CloudFormation. These are the modules we will cover during the course. Each module includes 1 or 2 lab exercises. They also include several recorded videos to show you how to interact with the AWS services through the AWS Management Console and the AWS command line interface. You will now learn about AWS documentation. You can find the documentation by pointing your web browser to the URL http://docs.aws.amazon.com. That is http://docs.aws.amazon.com. This is your primary reference site for all things AWS. You will now have a look at the documentation. We can open the browser to the documentation homepage. The AWS documentation is divided by service. The services are grouped by service category or service area. We call it compute, storage, networking, database, and many others. Each service includes 1 or more guides depending on what you want to do. It is common to see an administrator guide to learn how to set up and configure a service, and later see a developer guide to learn how to interact with the service using its application programming interface. Each AWS service has its corresponding documentation. So let's take a look at the S3 documentation. Here, you have a sample guide for Amazon Simple Storage Service, or Amazon S3. The S3 documentation has 4 guides: the Getting Started Guide, the Console Users Guide, the Developer Guide, and the API reference. The exact number and audience for the guides changes depending on the service. You're now set up to continue with this course on how to find information about AWS services. Thanks for watching.
Hello. In this video, we will introduce you to systems operations on Amazon Web Services, or AWS. We will start out by reviewing some of the core services you can use to automate repeatable processes in the cloud. We will also describe AWS regions and availability zones. Finally, we will cover how AWS Identity and Access Management, also known as IAM, can control access to AWS services, and how to use the AWS command line interface, also known as the CLI. As part of this module, you will have access to demonstrations that illustrate how to create IAM users and groups and how to interact with services via the CLI. You will also have access to a hands-on lab where you'll install and configure the AWS CLI. Finally, we will review some sample certification exam questions to test your understanding of the key concepts covered in this module. After completing this module, you should be able to describe systems operations in the cloud and explain how to automate cloud operations. You will also be able to explain to a colleague how to control access to AWS services using IAM, as well as how to install and configure the AWS CLI. Finally, you'll be able to describe the difference between AWS regions, availability zones, and edge locations to determine the appropriate regions for an AWS implementation. We're ready to go? Let's get started. Hello, you will now be introduced to systems operations in the cloud. Let's begin by defining systems operations. Systems operations include the tasks required to build, test, deploy, monitor, maintain, and secure computing systems. In the cloud, this is accomplished by building infrastructure with reusable templates or scripts. Reusable templates enable you to automate infrastructure deployments instead of building all the pieces by hand. In this course, we will discuss in depth some of the possibilities for packaging reusable infrastructure. Automation of deployments varies in the use of scripts, programs, or templates. For example, you can use a Linux shell script, also known as bash, a Python or Ruby application, a C# application, or a template format such as AWS CloudFormation. We will be covering AWS CloudFormation templates in depth later in this course. Specifying infrastructure details either declaratively or programmatically enables you to create as many deployments of the infrastructure as needed, and whenever you need them. The goal is to make the creation of the infrastructure as repeatable as possible. You can easily deploy an infrastructure you define once into different regions, or you can create development and test environments to match your production environment. Let's review some of the core services you'll use to manage operations in AWS. There are three key areas to focus on for network operations: network, compute, and controlling access. You use Amazon Virtual Private Cloud, or Amazon VPC, to configure network environments in the cloud. You launch resources, such as an EC2 instance, into the VPC network environment. The VPC provides greater control over the isolation of the environment and its resources from each other. Each VPC is defined within a region. You can have multiple VPCs in each region, and you can have VPCs in as many regions as you want. Within the VPCs, you will also create subnets, which can be either public or private. AWS provides a number of compute options. Amazon EC2 lets you provision virtual computing environments in the cloud. Anything you can do with a server on-premises, you can also do with an Amazon EC2 instance. Most server operating systems are supported, including Microsoft Windows, Red Hat Linux, SUSE Linux, Ubuntu, and Amazon Linux. You can create images of the servers at any time with a few clicks or a simple API call. These images are referred to as Amazon Machine Images, or AMIs, and you can use them to launch duplicate instances. Amazon EC2 is highly scalable, which means that you can add more instances when needed and terminate these instances when they are no longer needed. You can select the instance types you need based on parameters you want to optimize, such as CPU, memory, storage, networking capacity, graphics processing, or you can select a general purpose. Each optimized instance type comes in a variety of sizes to fit your project or business needs. Controlling access is the third major area of systems operations. You use AWS Identity and Access Management, or IAM, to control access to AWS resources for users and programs. You use IAM to control who can use AWS resources, what resources they can use, and in what ways. IAM supports granular control over access permissions, not just based on resources, but all the way down to determining which API calls for each service a user or a program can make. When assigning permissions to users, you should follow the principle of least privilege. For example, if you require administrative level permissions, you can create an IAM user, grant full access, and then use those credentials to interact with AWS services. Later, if there is a need to revoke or modify permissions, you can remove or modify any policies that are associated with that IAM user. Additionally, if there are multiple users that require access to an AWS account, you can create unique credentials for each user and define who has access to which resources. In other words, there is no need to share credentials. For example, you can create IAM users with read-only access to resources in an AWS account, and then distribute those credentials to users, such as auditors. Identity federation is another option with IAM. With federation, a user can use single sign-on or SSO to access AWS accounts using credentials from their corporate directory. Federation uses open standards such as Security Assertion Markup Language 2.0, or SAML, to exchange identity and security information between an identity provider, or IDP, and an application. Some AWS service features are regional, others are global, and others exist only in the availability zone in which they are created. It is important to understand the scope of the various features. For example, when a user defines an S3 bucket, they specify the region where that bucket will exist. Also, when you create an AMI from an EC2 instance, that AMI is only available in the region in which it was created. If you want to use that AMI in a different region, you must first copy it to the new region before you can use it to launch an EC2 instance. Amazon CloudWatch metrics, Amazon Elastic Block Store snapshots, Amazon Elasticache clusters, and VPCs are also all regional. It is important to remember that costs may vary by region. Also remember that different countries have different legal and compliance requirements for data governance. For example, a country's laws and regulations can affect what information can cross geographical boundaries. Finally, keep in mind that you can reduce network latency by placing resources nearer to your customers. Some resources are global. For example, when you define IAM users, groups, and roles, those resources can be referenced across all regions in an AWS account. Hosted zones that are defined in Amazon Route 53 and Amazon CloudFront distributions are also global. Some AWS service features only exist at the level of the availability zone. Every region has at least 2 availability zones. For example, if you launch an EC2 instance in the US West 1 region, it will be launched into an availability zone, such as US West 1B. If you then want to attach a new EBS volume to that instance, you must create the volume in the same availability zone, US West 1B. Otherwise, the EBS volume will not be able to attach to that instance. Subnets and Amazon Relational Database Service instances are other examples of objects defined within an availability zone. When you create a new AWS account, default service limits are applied. Some of these limits are soft limits. For example, if you want to run several on-demand T2 large EC2 instances in one region, the per region soft limit on those instances is 20. If you try to run a 21st instance when 20 instances are already running, you will get a capacity error. In that event, you would create a support case in the AWS Support Center and request a service limit increase for the account. These requests are often approved but may require further justification. There are also some hard limits. For example, the Amazon Simple Notification Service API has a throttling feature, and it has a limit of 100 subscribed transactions per second. Hard limits cannot be changed. If you want to learn more about service quotas or soft limits, search for AWS service quotas in the AWS documentation. Thanks for watching, and see you in the next video. Hello. In this video, we will introduce AWS Identity and Access Management. AWS Identity and Access Management, or IAM, is a service that securely controls access to AWS resources. IAM is used to configure authentication, which is the first step, as this controls who can access AWS resources. IAM is not only for user authentication, but is also used by applications and other AWS services for access. IAM is also used to configure authorization based on knowing who the user is and determines what resources users can access and what actions they can perform with those resources. IAM eliminates the need to share passwords or access keys when granting access rights to other people or systems. It also makes it easy to enable or disable a user's access over time and as appropriate. Think of IAM as the tool to centrally manage who can access, launch, configure, manage, and terminate AWS resources. It provides granular control over access permissions, not just for people, but for systems or other applications that might make programmatic calls to other AWS resources. IAM manages not just what resources can be accessed, but what action can be performed. For example, who can terminate Amazon EC2 instances? IAM also defines required credentials based on context, such as who can access which AWS service? What is the user or system allowed to do with the service? When you create IAM users, you can decide which methods they can use to access AWS services. You can give programmatic access, AWS Management Console access, or both. To provide programmatic access, create an access key ID and a secret access key, then provide them to the user. With these two items, the user will have access to the AWS APIs, the AWS command line interface, and AWS SDKs. You can give users access to the AWS Management Console by assigning them a username and password. The AWS Management Console provides a simple web interface for AWS. You can also set up multi-factor authentication, or MFA, which is a recommended best practice for added security. Once MFA is enabled, the user will need to enter an additional authentication code after providing their username and password. Every AWS account has an assigned root user in the root account. This root account has an assigned email address for the purposes of account recovery and communication. However, we recommend that you do not use the root user for everyday tasks, even administrative ones. Instead, adhere to the best practice of using the root user only to create an administrator IAM user first. Then securely lock away the root user credentials and only use them when needed to perform the few account and service management tasks that cannot be accomplished in other ways, such as canceling your AWS account. IAM policies are used to control access to AWS resources. There are 4 types of policies. First, there are identity-based policies. You can assign identity-based policies to users, groups, or roles. Resource-based policies are the second type. You define a resource-based policy with a JavaScript object notation document, also known as JSON document. Resource-based policies are only available for some AWS services. They provide a more detailed level of access control. For example, you could create a resource-based policy to limit access to specific EC2 instances. Resource-based policies do not always allow you to limit every action. For example, you can limit who can reboot an EC2 instance, but you can't specify that a user can run a specific instance. The third type of policy is a service control policy, also known as SCP. Service control policies are linked organizational units, which are groups of AWS accounts. You can use these policies with AWS organizations to limit access to AWS services. Finally, you can control access to AWS resources with access control lists, also known as ACLs. ACLs are similar to resource-based policies, but you don't define them with a JSON document. Here's a sample IAM policy. IAM applies policies based on the context of a request. This means the environment and resource data, the actions requested, and the specific resources requested are all evaluated. Also, whether the policy specifies to allow or deny the action is important. For example, if a policy explicitly denies access, that will override any statement to allow access. You can interact with roles either through the AWS Management Console or programmatically with either the AWS CLI or AWS SDKs. An application or a service, such as Amazon EC2, can assume a role by requesting temporary security credentials against a role that is then used to make programmatic requests to AWS. IAM roles also support single sign-on solutions. For example, an IAM administrator could configure SAML 2.0 federation instead of creating IAM users in an AWS account. With an identity provider, user identities can be managed outside of AWS, and these external user identities can be granted permissions to access resources in the AWS account by applying IAM roles. To learn more about single sign-on solutions, visit the AWS documentation and search for AWS Single Sign-On. An IAM user can assume an IAM role to temporarily elevate their permissions based on the policy attached to the role. When they exit the role, they return to their original permissions. A user can also switch roles to access resources for other accounts. This is known as cross-account access. If the cross-account access is used for an account owned by another person, it is a best practice to provide a shared secret known as an external ID. The external ID prevents one AWS account from acting as an account broker and handling the credentials for another account to a third account. The IAM administrator needs to set this up. To read more about how to use external IDs, search for external IDs in the AWS documentation. Roles have permissions policies that define what the role can do with temporary security credentials. The permissions can specify which AWS services the role can access and which actions are available. The policy can also restrict access based on time, date, source IP address, and other parameters. One way to simplify management of policies is the use of an AWS managed policy. AWS managed policies are standalone policies that are created and administered by AWS. These AWS managed policies can be used for many common use cases. For example, you can attach an AWS managed policy to a role to enable common Amazon S3 bucket operations. To read more about managed policies, search for managed versus inline policies in the AWS documentation. Let's discuss some of the AWS best practices. First, avoid using the root account credentials for daily administration. Second, always delegate administration functions following the principle of least privilege. Only grant access to services that are needed and limit permissions within those services to only the parts needed. Additional rights can always be granted over time if the need arises. Finally, use IAM roles to provide cross-account access. Other best practices for IAM that we mentioned earlier in this module include configuring strong password policies, enabling MFA for any privileged users, and rotating credentials regularly. You can find a full list of best practices for IAM by searching for IAM best practices in the AWS documentation. Thanks for watching. We'll see you in the next video.
Welcome. We've launched an Amazon EC2 instance, in this case, Linux 2, and we've connected to it using Secure Shell. The instance already has the AWS CLI pre-installed, and we're just going to run through an example of using the AWS CLI or AWS command line interface. Make sure you do the activity that is associated with this module, as it has you install the AWS CLI on a Linux instance. Great way to get that hands-on experience. So what we'll go ahead and do here is type in AWS configure. And my access key I'm prompted for, my secret access key. I'm in the US East 1 or Northern Virginia region, and my output is JSON. So now I can go ahead and enter different AWS commands. So in this case, AWS IAM list-users. And it shows me the users that we have in IAM. In this case, we have AWS student. And it shows when it was created, the user ID, and the Amazon resource name. So it's really powerful to go ahead and access the CLI through PuTTY. So you can go ahead and get a whole host of commands. So I've actually, this is one of our EC2 CLI command reference documents that's available on our website, and you can go ahead and look at all of the available commands. So there are a whole host. I'm not going to spend too much time here going through them all. I'm going to go ahead and select, for example, describe instances. And when I click describe instances, it goes through and gives you the definition, what is the description, and then the synopsis on what you can go ahead and do. So it shows different filters, instance ID values, the options that you can go ahead and use to pull. So there's a whole bunch of information here on using the CLI. You don't need to use it all. You can always go back in and type in AWS help, and you'll get information about the commands and the options in that. So it's easy to go through and find information about using the CLI. Remember, it's a powerful tool allowing you to get information out of your AWS infrastructure, to write scripts. You can do all kinds of things. So make sure that you're aware and familiarize yourself with the AWS CLI command reference and make it a part of your regular toolkit. Thank you.
It's now time to review the module, wrap up with a discussion of a practice certification exam question, and get started with the labs. In summary, in this module you learned about systems operations in the cloud and the AWS global infrastructure. You also learned how to manage security for your AWS implementation with AWS Identity and Access Management. Finally, you now know how to manage accounts and how to use AWS organizations, as well as some common uses for the AWS CLI. Great work! Look at a sample certification question. Take a minute to review a sample question that could be on a certification exam. Review this simple scenario and look for any keywords that will help you identify the correct answer. Here, the keywords in this scenario are highlighted. You can now look at the answer options. Keeping the keywords in mind, look at the answer options and try to rule them out based on the highlighted keywords. The best solution in this case is create a federated identity. There are two types of labs for this course. There are guided labs that provide you all of the steps you need to take to complete a task with AWS. There are also challenge labs for this course. These labs revolve around a fictional scenario. The scenario describes how a small business set up its operations with AWS. In the challenge labs, you will take on the role of various Amazon employees to help the business meet its goals. Let's have a look at your customers. Mom and Pop Cafe and Bakery had its start from a retirement dream. The owners, Philip and Emma, were not yet ready to sit around the house, and they wanted to do something that included their love of baking and supplemented their income. Philip and Emma decided to open a cafe in 2016. Their daughter, Sophie, and a secondary school student, Darsh, helped them out by working at the cafe. In recent years, they've experienced an increase in business and would like to spend less time doing administrative tasks. Sophie currently runs the cafe but is going to university next month to study business and programming. Sophie just learned about Amazon Web Services and told her parents that their services can automate the business. AWS services can help her parents focus more on what they want to do with the shop and reduce their administrative work. Darsh is leaving secondary school in the spring. He has worked at the cafe for almost a year. Since Sophie is going to university next month, it would be good for him to learn more about the cafe. He is excited to help out more. Darsh loves art and wants to be a graphic artist when he leaves school. He also loves technology and even designed the cafe's first website. The website is run through a hosting company, and Sophie even let him purchase the domain name. He wants to use the website to expand the social media marketing presence of the cafe. You will need to use the AWS CLI for many of the challenge labs. In the first challenge lab for the course, you install and configure the AWS CLI. Complete the Install and Configure the AWS CLI Challenge Lab to wrap up the module. Thanks for watching. We'll see you in the next video. Hello. You'll now be introduced to tools you can use to automate systems management on AWS. We will start by reviewing AWS Systems Manager and some core services you can use to manage and automate administrative tasks. You'll also review how to build out a static website with Amazon Simple Storage Service, or Amazon S3. As part of this module, we'll provide you with access to a video that describes the features of AWS Systems Manager. You'll also work on a hands-on lab where you will interact with AWS Systems Manager and work on an activity where you install a static website by using Amazon S3. Finally, you'll look at some sample certification exam questions to test your understanding of the key concepts covered in this module. After completing this module, you should be able to describe the features of AWS Systems Manager. You will also be able to explain how to use AWS tools for PowerShell, as well as additional tools for automating administrative processes. Finally, you will be able to describe how to use Amazon S3 to host a static website. We're ready to go. Let's get started.